Hey folks, Bill Armstrong here. I thought we'd work through some of the problems that I put out there for practice test number 2. So let's try number 1. In number 1, let's see, you were asked, or I asked you to evaluate and simplify f of x plus h minus f of x all over h for the function x squared plus 9x minus 8. So, if you're asked to evaluate and simplify f of x plus h minus f of x all over h for a function, and here it was for the function f of x equals x squared plus 9x minus 8. What you simply have to do is you have to compute the f of x plus h, and then you have to subtract f of x. That's f of x. And then divide that by h. So why don't we start off by evaluating the f of x plus h. This is just evaluating a function. Just like how you would evaluate the f of 3 or the f of 5. Wherever we see an x, we're going to toss in an x plus h. So let me do that over here to the side so I don't get this all cluttered. The f of x plus h. Now wherever I see an x, I'm going to put in an x plus h. X plus h is going in for the x. So x plus h should go in here for x, and x plus h should go in there for x. So look what that gives us. An x plus h squared plus 9 times x plus h minus 8. Okay, now we have a little bit of work to do. We have to take the x plus h, that quantity, and square it. So that would be x plus h times x plus h. And that will give us an x squared plus a 2xh plus an h squared. Distribute the 9, gives us a 9x plus a 9h, and then we have the minus 8. Just barely got it on the board. So right here is the f of, all of that mess there is the f of x plus h. So now why don't we take this result, since that's the f of x plus h, and we'll put it right in here for the f of x plus h. So f of x plus h, it's this mess. So that's x squared plus a 2xh plus an h squared plus a 9x plus a 9h minus 8. And now we have to subtract off f of x. So we're going to subtract off, kind of block that off. We're going to subtract off the f of x. That was f of x. Make sure, since f of x is a trinomial, there are 3 terms, and it's preceded by a subtraction sign, I will put it inside parentheses so I don't make a careless sign mistake. So before we go any further, let's make sure we see what we have here. All of this right here is f of x plus h minus, there's f of x. And then all of that junk is over h. So now if we just go ahead and distribute that negative 1, we have an x squared plus a 2xh plus an h squared plus a 9x plus a 9h minus an 8 minus an x squared minus a 9x plus 8. And then all of that junk is over h. And then a neat thing should happen. In fact, let me get one of my favorite colored chalk, red, because some things will cancel out. X squared minus x squared. They are gone. 9x minus 9x. That's gone. And then here's a negative 8 plus 8. That's gone. Look at everything we had to cancel out, so we're just left with, in the numerator, a 2xh plus an h squared plus a 9h. And then that's just over h. And now we're almost done simplifying. I mean, if you look in the numerator, you could factor out an h. So if we factor out the h in the numerator, we have that. And now since we could factor out the h, we can cancel it out. And that gives us 2x plus h plus 9. So that is what we get when we evaluate and simplify f of x plus h minus f of x all over h for the function x squared plus 9x minus h. So hopefully you got that for number 1, and things are looking good so far on this practice test for number 2, for test 2. Hey folks, here on number 2, you were asked to find the domain for the function h of x equals x minus 2 over x cubed minus 49x. Remember, domain will be the values you could put in for the independent variable. Here the independent variable is x. So it's values you can put in for the x so that nothing bad happens. Since we have a function that's a rational function, it looks like a fraction. What could happen here that is bad would be putting in a number for x that would cause the denominator to be 0. We can't divide by 0. So what our task is, what the game is we have to figure out those values of x that would actually make the denominator equal to 0. Those values of x cannot be in the domain because we cannot divide by 0. So why don't we go ahead and take the denominator, which is x cubed minus 49x, and let's set that equal to 0. Let's find the values of x that would make the denominator equal to 0. This is a friendly little equation to solve. Factor out the x, and that leaves you with x times x squared minus 49. This is the difference of two squares, so it would factor to x times x plus 7 times x minus 7. And then if you set each of these factors equal to 0, you will find that for x equals 0, x equals negative 7, and x equals 7, those three values of x would make the denominator equal to 0. These are the three values of x that we cannot allow to be in the domain. We can't divide by 0. So I asked you to write the domain in interval notation. So here's what it would look like in interval notation. We can pick any negative number we want up to a value of negative 7. So domain starts off negative infinity to negative 7. We can't pick negative 7, hence the parenthesis around negative 7. Now we can pick any number we want from negative 7 up to 0. So we'll union this with negative 7 up to 0. Now we can pick any positive number from 0 up to 7, can include 7. And I've run out of room on my chalkboard to keep going this way, so let me string it down here. Union with 0 to 7. And then we can pick any number we want that's larger than 7. So that's finally written as union with 7 to infinity. So these three values of x would make the denominator 0. These three values of x are not allowed to be in the domain. Can't put them in for x. 0 would be in the denominator. That's bad. And these three values of x allows us to write the domain in interval notation as, that's the domain in interval notation. So hopefully you have this for number 2. Hopefully it makes sense what a domain is. In general, domain are values for the variable. Values you can put in for the variable x so that nothing bad happens. Dividing by 0 is bad. That's it. Hey folks, back here the next one I thought we'd look at is number 6. You have answers for all of these. I had on the website. But quickly, number 3. Number 3, since the graph is symmetric about the origin, it's an odd function. For number 4, when you classify function values as positive, negative, or 0, keep in mind that if the point, if you're looking at a graph, if it's above the x-axis, the functional value will be positive. The y value, the functional value, is positive. If it's below the x-axis, the functional value, the y value, would be negative. And if it's right on the x-axis, then the functional value would be 0. Number 5 was making a graph of a piecewise defined function, and I supplied you with that on the answers. So I thought we'd look at number 6 here. In number 6, you were basically asked, how would you get the graph of this function using the basic graph of y equals x squared? And I think I said here, list 3 transformations. I'll probably end up writing down 4 transformations, and then I'll show you which 2 could be combined into, 1 transformation. So here's how I'll kind of organize my work. I'll kind of make a little column here that I'll call the transformation, what we're going to do, and then what the resulting function would be. Okay, now keep in mind we're starting with the function y equals x squared. So the first thing I do is I'd say, well, if we start with y equals x squared, if we shift it left 1 unit, then the resulting function we would end up with from what we're given, y equals x squared, would be y equals x plus 1 quantity squared. So you see, by taking this and shifting it to the left 1 unit, it gives us this function. Notice how we're getting closer to what I gave you. Okay, the next transformation I would write down is, let's do a vertical stretch by a factor of 2. When you do a vertical stretch by a factor of 2, it's just going to take what we have here, and you're just multiplying it by 2. Okay. But I do notice that it's the negative sign. It's a negative 2 out front. So the next transformation, I would say, take the graph and, flip it. Flip it over the x-axis. Okay, the more mathematical phrase may be you take the graph and you reflect it over the x-axis. I'll say flip, because I like to say the word flip. When you do that, to make something go over the x-axis, reflect over the x-axis, or flip over the x-axis, that's what brings the negative sign in. It would be these 2 steps right here that you could combine into one. You could combine these 2 individual transformations into one transformation. And you could say, for one step here, you could say flip it over the x-axis and stretch it vertically, or do a vertical stretch by 2. So you could combine these into one transformation. Finally, the only thing we have to do is take care of the minus 2, and I'm sorry, that should be a plus 2. So finally, to take care of this plus 2, all I have to do is take where I'm at right now, and that plus 2 is a vertical shift. So that vertical shift, since it's a plus 2, that means I'm going to take where I'm at right now, and I'm just going to move it up 2 units. So I'll write that down here as, let's just call it a vertical shift. Let's just say up 2, or up 2 units. And that gives us y equals negative 2, x plus 1 quantity squared plus 2. So that's how we use the basic graph of y equals x squared to eventually get the graph of the function negative 2, quantity x plus 1 quantity squared plus 2. Just like this. Hopefully it makes sense, and hopefully at this point on the practice test you're saying, I'm ready for the test. That's it for number 6. Alright, hey, here in number 7, I gave you 2 functions, f of x equals 4x minus 3, and g of x equals 2x squared plus 14x plus 3. And I asked you to do two things, part A and B. Part A, I asked you to evaluate f divided by g of 5. Keep in mind, f divided by g of 5, that is nothing more than f of 5 divided by g of 5. So you have to determine what f of 5 is. You have to determine what g of 5 is. Well, to get f of 5, you're going to put 5 in here for the x's. So let me write that over here real quick. For f of 5, you'd put the 5 in for the x's, so you'd have a 4 times 5 minus 3. That's 20 minus 3, that's 17. So f of 5 is 17. To get g of 5, well, you'll toss 5 in for the x's in function g. So let me do that right here. G of 5 would be a 2 times a 5 squared plus a 14 times 5 plus 3. So that's a 2 times a 25 plus 14 times 5, that's 70, plus 3. So 50 plus 70 plus 3 should give you 123. G of 5 is 123. So here's the answer to part A. That's f divided by g of 5. In part B, you were asked to just simply determine the f divided by g of x. Well, f divided by g of x, that's nothing more than f of x over g of x. F of x is 4x minus 3, so f of x is 4x minus 3 over g of x. Well, there's your g of x, 2x squared plus 14x plus 3. And that's it for part B, f divided by g of x. So that's it for number 7. Hey folks, here in number 8, I said to use the functions 4 over x plus 3 and 5 over 6x and to determine the composite function f composed with g of x. And, I would say the best way to begin this one is to write down when you do f composed with g of x, that you should just immediately rewrite this as f of g of x. That's the definition of composition. And then it's a matter of just substituting, plugging and chugging. In other words, bad equal sign. Let me make another one. The f of g of x, well, g of x is 5 over 6x. So we take 5 over 6x and just put it in here for g of x. So we have the f of 5 over 6x. Now we're evaluating a function. The way you always evaluate a function is you take whatever it is in here and you toss it into whatever the function is for the variable x. I mean, if this said the f of 2, you would take 2 and put it into function f wherever you see an x. This says the f of 5 over 6x. So we take 5 over 6x and we toss it into function f wherever we see an x. Well, that's the only x, so we take 5 over 6x and put it in here for x, and that gives us a 4 over 5 over 6x plus 3. I know, that looks horrible. I'm not a big fan of fractions, and when I have a fraction and there's a fraction in the denominator of my fraction, but I really don't like that at all. So here's what I'm going to do to get a more aesthetically pleasing answer, the correct answer, if you will. I'm going to multiply this fraction by the number 1. And the version of the number 1 I am going to multiply it by is 6x over 6x. 6x over 6x is 1, but notice what happens. Remember to multiply two fractions together. It's numerator times numerator. So that gives me a 24x. And then it's this denominator here, 5 over 6x plus 3 times 6x. Well, when 5 over 6x gets multiplied by 6x, you're just left with 5. And then when 3 gets multiplied by 6x, you have an 18x. And while I don't like fractions, I do think this simplified answer is a little more pleasing to look at than this ugliness here. So that's what you should have for number 8, for the f composed with g of x, or sometimes I call it the fog of x. You should have 24x over 5 plus 18x. That's it for number 8. All right, hey, now I thought the next one we'd look at is number 10. Quickly, let me say something about number 9. You were asked if the function was a one-to-one function, and to give an explanation for why you're answering the way you do. Quite simply, I would look at the graph, and I would see that it does not pass the horizontal line test. So I would say it is not one-to-one, and because it is not one-to-one, and I know it's not one-to-one, it does not have an inverse function. You weren't asked anything about an inverse function here. I'm kind of continuing the information. So, number 9, not one-to-one, fails the horizontal line test. In number 10, we're asked to find an inverse function. So really in number 10, I am telling you that this is a one-to-one function. It will have an inverse function. Let's find the inverse function. Here's how I go about finding the inverse function. The first thing I do is I write down the function. Okay, and I kind of have like a 4-step process. And I'll just kind of write the steps out here to the side. Step 1, pretty easy step. Replace the function notation, that's f of x here, replace it with the variable y. So look, step 1, pretty easy. I replaced f of x with y. Step 2, I switch my x's and y's. Well, so over here's a y, I'm going to now make that an x. Over here's the x, I'm going to make that a y. So I'm going to say step 2 is pretty easy. Step 3, this is like where the real magic takes place in step 3. I look at the equation that I have, and I have to solve it for y. So I have to take this equation and solve it for y. So that's my step 3. Let me bring it up here because I'm going to need a little bit of room. I'm going to take x equals 2 over 7y minus 3, and I'm going to solve that for y. I would start off by multiplying both sides of the equation by 7y minus 3. That will give me x times 7y minus 3 equals 2. I would then distribute this x to get 7xy minus a 3x equals 2. I would add 3x to both sides to give me a 7xy equals a 2 plus a 3x. And then finally, solving for y, when I get y all by itself, I'll divide both sides by 7x, and that gives me y equals 2 plus 3x over 7x. So I've solved for y. Step 4, it's another easy step. Replace y with the appropriate inverse function notation. So what that means, since I started off, my function notation was f of x, I'll replace y with the inverse notation, f inverse of x. I mean, if the function had been called g of x, then here I would have g inverse. But that's it. That's the inverse function. It's the process I use. That's my 4-step method. In any event, I hope that's what you have for the inverse function. That's it for number 10. All right, folks, here number 11. I gave you a quadratic function, x squared minus 8x plus 7. and I asked you to do 4 things. So the first thing I asked you to do was get the coordinates of the vertex. Before we do that, the one thing that I would notice is, there are 4 parts here. A, we're going to get the vertex. B, the x-intercepts. C, the y-intercept. And then in part D, we're going to sketch the graph. So the first thing I would kind of look at before I begin anything is, since I'm going to do the graph eventually, what kind of parabola is that? I know a quadratic function has a graph that is a parabola, and then there are 2 types of parabolas. You either have a parabola that opens up, I call that a happy parabola, or a parabola that opens down. Yeah, I call that one a sad parabola. Remember, in this form, if the number in front of x squared, that's a, if it is positive, you're going to have a happy parabola. If it were negative, you have a sad parabola. So here, a is positive, it's 1, a positive 1. So I know my graph, when I eventually get to part D, I know my graph has to be a happy parabola, which also tells me the vertex has to be a minimum. It's just a little bonus information. In any event, for the vertex, we have a nice, neat, short, sweet formula that will tell us the x-coordinate of the vertex. That's a negative b over 2a. So the x-coordinate of the vertex, for this one, it's the opposite of, well, b's negative 8, so we have the opposite of negative 8 over 2 times a is 1. So we have 8 over 2, which is 4. That's just the x-coordinate of the vertex. We need to also get the y-coordinate. The vertex is a point. It has an x-coordinate and a y-coordinate. So to get the y-coordinate, you just have to take the 4, toss it in here for the x's. In other words, you evaluate the function at 4. So we toss the 4 in for the x's. And let's see, 4 squared 16, 8 times 4 is 32. 16 minus 32 plus 7, it looks like we're going to get a y value of negative 9. So the vertex, it occurs at the point 4, negative 9. So that's your answer for part A. The vertex is the point 4, negative 9. Part B, find the x-intercepts. So for part B, to get those x-intercepts, well, remember in general, to find x-intercepts, you let y equal 0. I mean, that's been true for graphs ever since you've been graphing. So let y equal 0. Put 0 in for y. Here, that's f of x. So you put 0 in there, and you have a nice little quadratic equation you have to solve. Fortunately for us, this one factors to x minus 7 times x minus 1. Set each factor equal to 0, and you'll see x is 7 or x is 1. That tells us the x-intercepts. Remember, they're points. Points have an x-coordinate and a y-coordinate. So the x-intercepts occur at the points 7, 0 and 1, 0. So we have the vertex at 4, negative 9, 2 x-intercepts, 7, 0 and 1, 0. So now to move on to part C, I'm going to have to do a little erasing. And part C, we're asked to find the y-intercept. Well, just remember, to find the y-intercept, you're going to let x equal 0. So you put 0 in for the x's, and you get the y-intercept. Look at that. 0 squared minus 8 times 0 plus 7. You get y equals 7. So again, it's a point. The y-intercept is at 0, 7. Part D, I asked you to sketch a graph and use the points, use everything you found in parts A, B, and C. So let's see, I'll try to do a graph here. I'll warn you now, I'm not the best artist. Let me get some scaling on here. So this is 1, 2, 3, 4, 5, 6, 7. 1, 3, 4, 5, 6, 7. I'll get some over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me plot the points that we found in A, B, and C. We know the vertex is at 4, negative 9. 1, 2, 3, 4. Let's way down here. So about right here's the vertex. Let me label that 4, negative 9. X-intercepts at 1, 0, and 7, 0. So x-intercept at 1, 0, and 7, 0. So we found in part B. In part C, we found the y-intercept was at 0, 7. So there's the y-intercept at 0, 7. And remember what we started off? I started off by saying, since A is a positive number, that means we have a happy parabola. Sure looks like it's a happy parabola. So now I'll try to make a graph. Put an arrow there. Put an arrow there. Oh, make that point bigger so I hit it. And that's a rough sketch of this function. So hopefully you have all the parts there for number 11, and that's it for 11. All right, folks, here at number 12. I supplied you with the graph of a quadratic function. I told you the vertex was at 1, 9, the y-intercept was at 0, 8. I'm not going to sketch that graph because you should have it in front of you. I see it's a sad parabola. That tells me A has to be negative. It's a sad parabola. And I asked you to do 3 things here. In part A, I asked you to use the coordinates of the vertex to put the function in the form f of x equals a quantity x minus h squared plus k. Since the vertex, I told you the vertex was at 1, 9. So since you know the vertex is at 1, 9, it's pretty straightforward to say, well, HK, HK. So it's A times the quantity x minus 1 squared plus 9. That's it for part A. Just substituting the h and the k in here for h and k. That's it. Now part B, I said use the coordinates of the y-intercept to actually determine this value of A. So in part B, since I told you the y-intercept was 0, 8, to determine the value of A, all I have to remember, this is x, this is y. So I put 8 in here for y, I put 0 in here for x. So when I do that, I have 8 equals A times 0 minus 1 squared plus 9. 0 minus 1, well that's a negative 1. Negative 1 squared is positive 1. So A times 1 is just A. Subtract 9 from both sides. We've determined A has a value of negative 1. So since we know A has a value of negative 1, just kind of looking ahead here, part C, write the function in the form ax squared plus bx plus c. So look at what you're supposed to do in part C. This is what we got from part A. In part B, we determined A has a value of negative 1. Well, if we put that negative 1 in here for A, we see this is the function. There, I just put this -1 in here for A, and I have that. But we're asked to put it in the form ax squared plus bx plus c. Well, why don't we just go ahead and multiply this out, and take the x minus 1, that quantity, and square it, then distribute the -1. We'll be able to answer that question. So if I multiply out x minus 1 quantity squared, notice I kept that negative sign out of the parentheses. I'm doing this multiplying first. I get an x squared minus 2x plus 1. This is what you get when you take x minus 1 and square it. Now distribute that negative, and you get negative x squared plus a 2x minus 1. Now combine any like terms. Well, you only have two like terms, -1 plus 9. And you get negative x squared plus a 2x plus 8. So that is the answer for part C. So hopefully you had fun with number 12. You found it to be pretty friendly. That's it for 12. All right, folks, number 13. It's the last one that's going to be on this video. You're given a profit function. You're told that's the daily profit that a vendor receives from selling some pretzels. X is the number of pretzels that's being baked, and then P of X represents the daily profit in dollars. Part A, find the number of pretzels that must be baked and sold to maximize profit. And then part B, what is the maximum profit? That word maximum, I have to find the vertex. Anytime I have an application like this and I see max or I see a min, maximize or minimize, maximum or minimum, I should be thinking find the vertex. And it should make some sense here in that, when you look at this profit function, A is a negative number. If A is a negative number, that means the graph of this parabola would be a sad parabola. It has to have this shape. It's a sad parabola. Of course, this point up here is going to be the maximum. That is the vertex. So we need to find the vertex here. And remember our handy-dandy little formula? The x-coordinate of the vertex is negative b over 2a. Yeah, we're going to use that again. It's a negative 1.6 over 2 times negative 0.002. I'd use my calculator here, and I get an x value of 400. So that's the x-coordinate of the vertex. The y-coordinate of the vertex, again, that's found by taking this number here, 400, tossing it in for the x. So you evaluate the function at 400, and I use a calculator, folks, and I get p of 400 to be 70. So think about what you found. You found the coordinates of the vertex are 400, 70. This is the x-coordinate. This is the y-coordinate, or the p of x, if you will. You should be able to answer any question. In particular, in part A, you are asked, find the number of pretzels that must be baked and sold to maximize profit. Well, x represented the number of pretzels. We have an x value of 400. That's where the vertex is. So that's your answer. 400 pretzels must be baked and sold in order to maximize profit. Part B, what is the maximum profit? P of x is the profit. P of x is the profit. P of x, that's the y-coordinate of the vertex. So the maximum profit is $70. Okay, I would probably tell these pretzel-making people, do something else. It's not a whole lot of money for making 400 pretzels. But in any event, those are the answers. And, for 14 and 15, they're not going to have those on the video here. This is the last one. Hopefully you're feeling pretty good. You're feeling confident coming up on this on test 2. Make sure you know exactly when the deadline is, the last day that you can take test 2. And that's it. Thanks for watching.